In this video, we will present the concepts required to size conductors for circuits installed in underground duct banks, using the Sizer Electric software. Before starting the data entry process, let us review the commonly used engineering approaches for conductor selection in duct banks. In general engineering practice, two methods are recognized. The first method, which is implemented in Sizer Electric, applies the conductor ampacity tables defined in the National Electrical Code or in the Mexican Official Standard NOM 001 Std 2012, hereinafter referred to simply as the code, along with the adjustment factors for cable grouping in duct banks, defined in the IEEE 399 standard. The second method is the Nair-McGrath thermal image method, which calculates conductor ampacity or operating temperature while carrying load current. The first method is widely accepted and recognized by the electrical engineering community. However, it is a conservative approach and may result in slightly oversized conductors. The second method is more accurate, but it requires detailed system modeling using specialized duct bank calculation software. It's time-consuming, and must be reviewed and supervised by qualified engineering personnel. Sizer Electric applies the first method, therefore, it is important to understand its scope. The standard considers only 3 installation details for underground ducts and 6 installation details for directly buried cables. For duct banks, only the following configurations are considered. Detail 1, 1 conduit per bank. Detail 2, either a 2x2 layout or a 1x3 layout. Detail 3, either a 3x2 layout or a 2x3 layout. It is also important to note that, according to Note 1 of Figure 310/60 of the Code, the minimum burial depth to the top of electrical ducts or cables must comply with Section 300-50 of the standard. Equally relevant is the fact that the maximum reference depth used to determine ampacity from the tables, from finished grade to the top of the duct bank, is 750 mm. Likewise, the maximum depth from finished grade to the top of directly buried cables is 900 mm. For greater depths, ampacity derating factors apply. Another relevant consideration is that the ampacity tables 310-60, C77, through 310-60, C85, as well as tables B.310, B27, through B.310, B210, in Annex B of the Code, applicable to duct banks and directly buried cables, are calculated based on a soil ambient temperature of 20 degrees Celsius. This differs from other ampacity tables for air or raceway installations, which are referenced to 30 degrees Celsius or 40 degrees Celsius ambient temperatures. This temperature reference is critical because temperature correction factors must be based on the 20 degrees Celsius soil reference temperature. The temperature affecting conductors in ducts is the average soil temperature, not the ambient air temperature at the installation site. It is important to clarify that the correction factors shown in Table 310-60, C, for titled ambient temperature correction factors, do not apply to ducts or directly buried cables. Ampacity variations due to soil temperature changes are calculated using the formulas in Section 13.4.1 of IEEE 399, considering the new soil temperature obtained from a geoelectrical soil profile study conducted at the installation site. Finally, it is important to understand that the ampacity tables for underground ducts and directly buried cables, defined in the code, assume the following 3 conditions. All conductors in the duct bank operate at 100% load factor, meaning all cables carry current equal to their ampacity. All conductors in the duct bank have the same conductor size. The soil thermal resistivity is assumed to be ρ equals 90 degrees C centimeters per watt. Because these 3 conditions are rarely met simultaneously in real installations, ampacity calculations based on tabulated values generally result in slightly oversized conductors when compared to a Nair-McGrath modeled solution. Another challenge in duct bank conductor selection is that project requirements often demand more ducts than the layouts shown in details 1, 2, or 3 of the standard. To calculate duct banks with configurations different from those listed, it is necessary to apply the adjustment factors defined in Standard IEEE 399. This is done by calculating the base conductor ampacity and applying the adjustment factor obtained from Tables 13.8 and 13-9 of the Standard IEEE 399, based on the number of rows and columns in the duct bank arrangement. This factor is multiplied by the conductor current obtained from the ampacity tables for Detail 1, 1 conduit per duct bank. The single duct configuration serves as the reference ampacity, since it does not account for thermal contributions from adjacent ducts. Let us now review how these criteria are applied within the Sizer Electric data entry interface. In the Raceway field, select Duct for duct bank installations, or select Direct Burial for directly buried conductors. Select Duct. This will display the data entry window for installation details. In the Duct Type field, select Detail 1, 2, or 3. Note that the selected installation detail will be displayed graphically at the bottom of the combo box. On the right-hand side, within the Adjustment Factors frame, you will find options to modify the base conductor ampacity. First, select the harmonic load content, expressed as a percentage, to derate conductor ampacity in accordance with standard IEEE 141. Next, select the number of current carrying conductors in the conduit to determine the applicable adjustment factor. If the duct burial depth exceeds that shown in the ampacity figures, greater than 75 cm for ducts, or 90 cm for directly buried cables, the ampacity will be reduced by 6% for every additional 30 cm of depth, in accordance with Section 310-60, c. 2, of the standard. Enter the burial depth in centimeters, and the application will calculate the corresponding derating factor automatically. Define an additional derating factor if the cable shield is grounded at 2 or more points. If a specific adjustment factor is required, enter the factor name and provide a value between 0 and 1. If the soil temperature exceeds 20 degrees Celsius, update the temperature value. The application will calculate the corresponding ampacity adjustment factor in accordance with Section 13.4.1 of Standard IEEE 399. The ampacity tables for conductors installed in ducts assume a soil thermal resistivity, ρ, of 90 degrees C, centimeters per watt. If a geoelectrical study indicates a higher soil thermal resistivity, you may modify the ampacity using the adjustment factor option. Enter the new soil resistivity value and the number of associated circuits. The application will calculate the adjustment factor based on Table 13.15 of Standard IEEE 399. Due to the limited duct bank configurations defined in the code, it is common to require calculations for duct banks with more conduits. For example, a 4-row by 8-column duct bank arrangement may be required. In this case, enable the option, Use Duct Grouping Adjustment Factor, and specify the actual number of rows and columns. Note that the maximum number of rows is limited to 4, and the maximum number of columns to 15. Conductor ampacity will be adjusted according to the grouping factors defined in Tables 13.8 and 13-9 of Standard IEEE 399. To apply this duct grouping factor, the selected duct type must be Detail 1, single conduit. This is because the adjustment factor methodology uses the single duct ampacity as the reference baseline from which derated ampacities are extrapolated. When this option is used, the application will display an informational message reminding you to select Detail 1. The final field, labeled Duct Derating Factor, represents the product of all applied adjustment factors. During data entry, this field displays no calc, since the conductor size must first be determined through an iterative selection process. Once the conductor size has been selected, this field will update to show the final assigned value. This completes the configuration required to determine conductors installed in ducts. Be sure to enter all circuit information and click Accept to view the conductor selection results. Afterward, you may return to the duct interface using the 3-dot button to review the adjustment factors applied. These are the fundamental concepts for calculating conductors installed in duct banks using Sizer Electric software. We appreciate your attention and recommend viewing the complementary videos covering conductor selection, cable tray and conduit selection, and grounding grid design for a complete understanding of Sizer Electric's capabilities.